Hi everyone, Jen here. I am at Simmons in the chemistry lab. Some of you might recognize it. My lab coat was still here, so I was happy about that. Today I'm going to be demonstrating our third lab where we are looking at alcohols, phenols, and ethers. So I'm going to share my screen and get right to the explanation of what I will be showing you today. Okay, so the first part of this demonstration, I will be conducting a solubility experiment, but using some chemicals and not household items. So those items I'm using today in lab are 1-butanol, 2-butanol, 2-methyl, 2-propanol. We have a phenol and we have diethyl ether. Just a quick thing to point out, I did look at the phenol in the chemistry storage and it has some hazardous labels on there. I also saw the safety precautions for this lab, and phenol is pretty toxic. So that goes back to what we were talking about last lab about that skincare product that had the phenol in it. So I think I'm a little bit more convinced than ever that there was a reason why that company stopped making their product with phenol in it. Anyway, so I will be doing a solubility test in water, which will be pretty quick. And before you're watching this video, you'll have completed a quick breakout room activity with your classmates to see if you can predict if these are going to be soluble in water or not. And you'll also make predictions about the second test that I'm going to be describing below. So the second test I'm going to be doing, you can just ignore the unknown substances there. We're going to be using all knowns. So all of these here, we're going to know what they are, and I'm going to be running these tests on them. So these are called colorimetric tests. They're basically color changes or formation of a precipitate, which is a precipitate is a type of solid substance or something that's not dissolving in a mixture. It either floats there or sits at the bottom, or it creates a film in your test tube. So those are what colorimetric tests are going to be. It's a color change basically, or it's any visual change that we can see, and that's how we're going to identify what's happening in our tube. What are we seeing, the behaviors that we're seeing with alcohols, phenols, and ethers with these three tests. So the first test is the chromic acid test. So I made the chromic acid reagent just now with chromium oxide and sulfuric acid. So it's this bright orange color here, just as a baseline. And so when you take a primary and secondary alcohol, so you'll have determined which one of these on that list above was a primary and secondary alcohol, those are going to form a type of precipitate, and you'll see a little bit of a color change, or a lot of a color change. I haven't done this before, but it'll turn a green color. Okay, so those are the reactions that you're going to see. If you don't see a change, if it stays orange, then you know that it wasn't a primary or secondary alcohol or a phenol. So let's go on to the next test that I will be doing is the ferric chloride test right here. So we use this test to distinguish phenols from primary, secondary, tertiary alcohols and ethers. And we're using a ferric chloride test reagent. So we're going to see that the phenols are going to react with that the iron. So Fe is the iron. So ferric chloride is iron 3 chloride. So the phenols are going to react with that iron, and they're going to form a red or purple color right there. So it's going to go from a clear color to a red or purple color, and that's just for the phenols. Then I'm going to be doing a Lucas test. So in the Lucas test, this is where we're going to see a type of precipitate that forms in a layer. So we're going to see that water-soluble primary, secondary, and tertiary alcohols can be distinguished using a mixture of zinc chloride. So Lucas test is basically a fancier name for zinc chloride that has hydrochloric acid in it, so HCl in it. That's what the Lucas test reagent is. So when you add the reagent, the tertiary alcohols are going to react and give you an insoluble white layer. So it's just like it sounds, it's a layer that's not dissolving, it's insoluble in the test tube. The secondary alcohols are going to react slowly. So I do have a water bath heating up where I'll submerge my test tube in the water bath and kind of speed up the reaction so we see a reaction in the test tube. And that'll give us a white layer after about 10 minutes of heating. And then primary alcohols don't react, and any formation of a heterogeneous phase or appearance of an emulsion is a positive test. So what does that mean? So heterogeneous is it's not mixing. So homogeneous is something that's mixing together, like homogenized milk is mixed together, but something that's heterogeneous is the components are separate from each other. They're not mixing, they're not miscible. So if we see that there's any type of separation or layers forming, then we know that we have a positive test. So if, for example, we're adding one of our chemicals to a test tube and nothing happens, then we know we did not get a positive result. But if we're seeing, let's see, if we're seeing something cloudy in the test tube, or we're seeing some type of solid, we know that we have a positive test, and that is going to be for our secondary alcohols and also for our tertiary alcohols. And we'll heat them as well and see what happens. Okay, so now I'm going to put on my PPE. I already have my lab coat. I'm going to put on my goggles and gloves and get set up, and I'll start filming. Okay, here we go. Okay, solubility. So these are my 6 test tubes. I didn't label it for this part because when I do the close-up of the test tubes where you can actually see if they were soluble or not, I'll label them. But I just wanted to show you the process. So all of my chemicals are just clear solutions. It feels really strange not wearing a mask right now. I don't know why. I think because the smells. I'm thinking, I can't believe we never wore something to not smell these things. But anyway, as long as you have the goggles and the gloves, you should be okay, or I should be okay. So anyway, these are my 6 test tubes. So I have 1 butanol here, 2 butanol there. This one is my 2-methyl-2-propanol. This is my phenol, and it's actually diluted in some water. And then this is my diethyl ether here. Okay, so write that down if you need to, but in the next part of the video where I do a close-up, you'll be able to know what's in them. So I also have my distilled water here, and I'm gonna add, so there's 10 drops of each of those in the test tubes already. And now I'm going to add 2 milliliters of distilled water to each tube to see if they are soluble. All right, so I labeled as best I could with what I have, which is tape and paper. So we're going to be looking at our 1 butanol, and as you would expect, it's soluble in water. Next we have our 2 butanol. I actually added a little bit more water to this one just to be able to visualize it a little bit better, because I actually couldn't tell. And we see that 2-butanol is also soluble in water. Next we have our 2-methyl-2-propanol. That brown is just residue on this
unclean test tube, so it's on the outside, it's not on the inside. And our 2-methyl-2-propanol is also soluble in water. Next we have our phenol, and what I meant earlier that it was diluted in water, the phenol is, I think because it's so concentrated, the phenol was diluted in water, you know, and put into a dropper, and then I further diluted it essentially and added more water to it. So the phenol is also soluble in water. Last we have our diethyl ether. So this one is just slightly soluble.
All right, so I finished my solubility experiment. I'm going to conduct the chromic acid test on my test tubes. So I actually already started, but let me walk you through what I'm about to do. So in clean test tubes, I have 10 drops. I have my 1-butanol, 2-butanol, 2-methyl-2-propanol, my phenol, and my diethyl ether. And my chromic acid solution is this burnt orange color, which looks correct, but hopefully it works. So I've already added, I only added 1 drop to this test tube because this is the second time I'm doing this, and it became very, very dark. So I don't know if maybe I used a sulfuric acid solution that was too concentrated, or maybe this is just fresh and these are much older. I'm not sure. So I ended up just using 1 drop in this test tube. So I think I'm gonna just do 1 drop in each, but I should have done 2 ideally. So 1 drop in there, drop in there. All right. So I'm going to pause the video and show you a close-up of what I'm looking at.
Here we have our chromic acid test. We have our 1-butanol. I was hoping it would give me a bit of a green precipitate. If I look closely, I see a little bit of a green hue, but I'm wondering if it was I used a too concentrated sulfuric acid. But regardless of whether or not I see a green precipitate or not, I do see a reaction. So this alcohol, the 1-butanol, was oxidized because it didn't stay the orange color. So initially the 1-butanol was clear and I added that orange chromic acid. So if no reaction took place, it would just be an orange color. So we did see a reaction there. 2-butanol is the same. This is an example of no reaction occurring. So this is my 2-methyl-2-propanol, and no oxidation of an alcohol occurred with this one, which is what we would hope to see. So it just stayed that orange color. Our phenol,
Last but not least, our diethyl ether. No reaction there. So what I'm gonna do now is I'm gonna actually heat up my diethyl ether and my 2-methylpropanol in my water bath and see if anything happens. So for the sake of time, I already added the amounts that I needed to my test tube. So I have 10 drops of each of these and 2 drops of my ferric chloride test. So I just want to show you what the ferric chloride test looks like. It looks like Sunny D or orange juice. And when I added it to my test tubes, I see no color change. It's basically just that clear liquid mixed with my Sunny D, aka my ferric chloride. So no change there. No change with 2-butanol. That was 1-butanol. This is 2-butanol. No change. 2-methyl-2-propanol. No change. That's a precarious position, but I think it's going to be okay. Here we go. Our phenol, we see a nice purple color. There we go. There's that nice purple. Last, our diethyl ether. No change there. Here we are, the final test of the night. We are doing the Lucas test. So I have put 10 drops of each of my chemicals. My labels are looking a little worse for wear, but anyway. So 10 drops of each of those and 1 milliliter. So a whole test tube of this, or a whole dropper full of this. It's a clear liquid. So if we're starting with all clear liquids and we're adding something clear, if we see any type of color change, any type of solute or precipitate rather, we know that positive result has occurred. So we have 1-butanol, which has stayed clear. Okay. 2-butanol. So it's looking a little bit cloudy, more so than my 1-butanol. I'm going to actually put this into my water bath. All right, it's been about 6-7 minutes. So my 2-butanol has been resting in its warm bath, and I do see a precipitate that formed with the Lucas test, which is what I was expecting to see. Next we have our phenol.
Nothing happening there. That is also clear. I'm not going to bother heating that one because even if I heat it, I'm still not going to see any change. And lastly, our diethyl ether. Again, no change there. Put it down. Is just clear.
That is all for me tonight. I hope you enjoyed this lab as much as I've enjoyed being back in lab and mixing chemicals. So just to go over what we've seen today, we did a solubility test. We did the colorimetric test, so the chromic acid test, the ferric chloride test, and the Lucas test. So I hope this was fun for you, and thank you for watching, and be well and take care, and I'll see you in Zoom. Bye.